Hi, and welcome, and thank you for joining us for the second webinar of our Spotlight series on PLM. My name is Michał Sieradzki, and I'm going to be your host for this session. Today's session will be presented by Matthias Holgersson, Marie-Fleur Revel, and Simon Pilhar. We highly recommend that you call into this webinar from your mobile using local numbers provided. For best experience, please also close all your other applications for the duration of this webinar. This webinar will take approximately 45 minutes, including a short Q&A session at the end. Since everyone on this call has been muted, please type your questions into your GoToWebinar control panel, and we will bring them up during the Q&A session. Now, without further ado, I will hand over the puck to Matthias.
Thank you. Good afternoon and warm welcome to all of you. My name is Matthias Holgersson, and I'm the head of our Scandinavian PLM Center of Excellence. First of all, I would like to thank you all for joining our webinar today. I'm really happy to see that we have so many participants in today's session. In this webinar series, we will talk about PLM and its role in the age of Industry 4.0. Today, we will talk about digital twins, from product lifecycle management to digital twin lifecycle management. We will listen to Marie-Fleur Revel and Simon Pilhar from Germany. They will talk about different digital twins and the intelligent linking between them. But first, I would like to take the opportunity to inform you about our capabilities and the background of the webinars. Since we have some technical issues last time, I will do the same introduction today. So next slide, please. First of all, I guess you all heard about Capgemini's acquisition of Altran. Two industry leaders joined forces to support customers throughout the entire life cycle of products and services. Together, we will focus on intelligent industry. Together, we will form a major global player with more than 270,000 employees in more than 40 countries. And in Scandinavia, we will now have more than 5,000 consultants to support our customers. Next slide. When it comes to PLM and digital manufacturing, we have a strong global presence. We have more than 1,500 consultants working within the PLM area all over the globe. As a technology-independent partner, we can deal with solutions at different platforms. We have both global and local strategic alliances with the major software vendors like Aras, Siemens, Dassault, and PTC. And we have a great global PLM footprint. As you can see in the lower right corner, we have customers in several different industry sectors like aerospace and defense, automotive, industrial equipment, high-tech, energy, consumer packaged goods, retail, and so on. Next slide, please. And from the beginning of this year, we have also established a local PLM team, a Scandinavian PLM Center of Excellence. And with this growing team, we will have the ability to support our Scandinavian customers, both locally and globally. And this team is just in its beginning, and we will continue to grow. At the same time, we will leverage the global capabilities we have and bring our global knowledge, experiences, and assets to our Scandinavian customers. Next slide, please. When it comes to end-to-end digital, we have a vision, and it looks like this. Many companies today are using CAD, PDM, or PLM for their engineering department. But to really get the maximum value out of these systems and to reach the goals, we need to think bigger. We need to implement an end-to-end digital thread and use the same data for manufacturing, after sales, and services. We need to connect the physical product with the digital twin and get real-time data back in the engineering process. First, then, we will have the chance to shorten time to market, improve our efficiency, reduce costs, and deliver the right product. And when we talk about the digital twin, it's not only about one digital twin. It's more about the digital ecosystem containing of several different digital twins connected together exchanging real-time data from design to use. And finally, next slide, please. Looking into the Industry 4.0 landscape, there is a lot to think about and take into consideration. As you all know, Industry 4.0 is about automation and data exchange in manufacturing technologies and processes. And PLM is actually the backbone of this landscape. For example, PLM provides the digital models in an up-to-date manner throughout the entire life cycle. PLM manages the product data and control the processes such as requirement management, change management, and approvals. PLM provides methods and tools for digital manufacturing to form the basis for factory and process planning. And as you all sure are aware of, PLM has transformed in the last 25 years. I mean, from a simple drawing management system to a cornerstone of enterprise IT alongside ERP, CRM, supply chain management, and so on. In the beginning, the focus for PLM was to managing product data and integrating CAD systems for mechanical design. But today, in Industry 4.0, the need for a digital thread, digital twins, and digital continuity have increased the complexity. PLM needs to manage globally distributed development processes. PLM needs to meet increasing demands from customers, such as systems engineering and for mechatronic products, or digital manufacturing for the integrated planning and development of production processes. So to summarize these, PLM has become an important Industry 4.0 driver. Its importance is really paramount, and the explanation is quite simple. PLM is the backbone of the landscape, and also a large reason for that digital factory transformation is happening in the first place. So, with this introduction and short words, I would like to hand over to Marie Fleur and Simon.
Yeah, thank you, Matthias, for the introduction. You said before, today we're going to talk about digital twins, and as you mentioned, we believe that there's not only one digital twin, but different digital twins for different life cycles of the product. And this is what we're going to talk about today. So speaking to you today are Simon Pielhaar and myself. So we are both from Germany. I'm the head of digital manufacturing for the application services in Germany. So I'm heading the IT people in the area of digital manufacturing in Germany. I'm responsible for the team, for skills and competencies. Also, I'm still working in projects myself as a project manager and also in early phases of requirements engineering. I work together a lot with our PLM partners, and I have a long-term experience in the automotive area. Okay, so Simon, if you would like to introduce yourself, please.
Yes, sure, Marie. Thanks for the introduction. And first of all, sorry to the audience that I'm just speaking to you out of the dark or out of the white. I don't know how to explain, but unfortunately, I have technical issues with my camera, so I cannot connect, and therefore, unfortunately, you just see the black and white picture, which is shown here on the slide. So just some short words about my person. I'm heading the digital manufacturing team in Germany for the entity of digital engineering and manufacturing services. My main areas where I have expertise and where I come from is on digital manufacturing and virtual engineering. Like Marie, I'm also still working as a project manager with a focus on application management. And from my perspective, I'm also doing PLM partner management and for sure supplier management. And from history and from expertise, I'm coming out of the aerospace and defense industry. Back to Marie.
Okay, thanks. So let's have a quick look at the agenda for today. So we're going to quickly introduce the topics, then talk about some theory behind it and how it can be put into practice. We're also going to show you some use cases that we have implemented at our clients and talk about best practices before we then talk a bit about how we do digital manufacturing projects at Capgemini. After that, there'll be a Q&A session. So feel free, as said before, to type questions in the chat already now. Yeah, and we'll read them out at the end of the session, and be happy to answer your questions. Okay, so let's get started. Digital twin, what is it? Yeah, so that's a very generalistic way of looking at it. It's of course a digital representation of some object or process that you want to improve. If you look at it from the IT perspective, usually you say, okay, it's a bit more complex than that. You have different subsystems that you want to have a look at, also at their interaction. You want to be able to simulate, and you also maybe want to be able to retrieve real-time data and analyze the behavior. If you look, if you go one step further and look at the part of innovation, and this is basically where we want to go today, is that you don't only want to have systems that you can simulate and collect data from, but you want to have a system that can improve itself. Yeah, by, for example, by using artificial intelligence or machine learning algorithms. You want to have a system of digital twins that can learn from each other and thus have a self-improving, self-learning system. Okay, next slide, please. So why? Well, what is behind it? I think most of you have already had a look at the topic, so maybe there's not much new about it to you anyway. I think it's very important to always question why should you do a digital twin project. So first of all, of course, you want to accelerate the time to market. This is, of course, be done by using the newest tools and techniques, which help you to work more efficiently. But the bigger and the more important part is really the second one, is the collaboration. Today, what we see in many companies is there's still silos in IT and in processes between the different departments that contribute to product development. Yeah, for example, engineering, manufacturing, also purchasing, supply chain, and so on. Today they work in process silos and also in IT silos, and this takes time. Yeah? So that one department has to finish the work before data can be handed over to the next department, for example. So it's very important that you create a digital thread with consistent data that is available early where you need it. Yeah, so you really want to manage the collaboration, which means you also have to change processes and also mindsets. Yeah, so it's always about changing ways of working. Another important topic, of course, is cost reduction. So, for example, in the design phase, you want to save costs by having very good simulation tools. This can save you money, for example, in testing, because you need to build less prototypes. You also want to save production costs. This can be achieved, for example, by achieving higher degrees of automation in your plant, or, for example, by doing automatic monitoring of your production line. And depending on the product, so if you also are a company that maintains the product, you also want to reduce that cost, which can be done, for example, by predictive maintenance. Yeah? So forecasting when the product should be maintained next, when is there a part that should be changed, etc. Another very important use case is to eliminate downtime. So, for example, if you think of a plant producing cars, every time you have a major change in the model of the car, for example, then you need to have a downtime in the plant to do all the changes in the plant. Yeah, and usually it means the plant is shut down for a certain amount of time, and then you can replace the machinery and the line and so on, and then restart the plant again. And usually it takes several test runs, yeah, because everything needs to fit in place, and usually there's not much space in a production plant. Today there's very good tools where you can do the simulation with, so you can model the whole plant with the lines. You can place all the machinery, the robots. You can also simulate if energy consumption or your tech times will change. You can even put people into the plant and have a look at the simulation. Like, can they still reach their tools? Do they have enough space to work and so on? And we did that for one automotive client. And before the implementation of the project, they had a downtime of about 72 hours on average for major changes in the model. And this downtime after the simulation went down to 24 hours. Yeah? So 2 out of 3 days could be saved just by having a better simulation of the plant change process. And you can imagine that there's a big business case, of course, behind it, because 2 out of 3 days of plant downtime could be saved. In the end, of course, what you also want to reach is to create a better product, which can be done basically by improving all the points before, being more efficient, and also by improving quality by having higher automation in the production process. Okay, so next slide, please.
Sorry, here we go.
Looking at the market trends, so this is the last slide for introduction. I'm not going to read out all the quotations because, as I said, if you've already had a look at the topics, I think some of this will be known to you already. Still, what I think is very interesting is to look at the numbers. So you can see that throughout the different industries, the digital twin market has been growing in the last years, but it's expected to grow exponentially in the years to come. And the reason for that is exactly what we talked about on the last slide, is that there's a big return on investment that you can achieve if you implement digital twin projects. So that much for an introduction. Now I'd like to hand over to Simon, who's going to explain, as I said, a bit about the theory behind it, how you can put it into practice, and also show some use cases.
Okay, thank you, Marie, for the introduction. And here's again the voice out of the dark. So, yeah, what do we speak about today? The digital twin, as such, is quite long used in product development and in design, and therefore, for all of us and for all of you, that's not really something new or disruptive. In the combination with new technologies like cloud, industrial IoT, and industrial and IoT, and with having the means of simulation analytics and to optimize the product along the whole life cycle, as well as the production, and with the new capabilities in the digital world, I think you all agree that what Marie just showed on the slide, that the digital twin is having a kind of renaissance. So, digital twin, what do we speak about? So Matthias already mentioned in his introduction that in the end we do not have one digital twin. We speak about different digital twins when you look at the overall life cycle. So first we have the product twin, and I think that's where most of us are coming from the CAD world, from the engineering world. Then we have the virtual production or the digital production twin, and finally the digital performance twin, which is the instantiated production as well as the product in use. Starting with the digital product twin, so what is it about? So this is more or less a complete representation of the product, including all mechanical and electrical systems, and in latest time, more important, the software, and as well including the behavior of the product. In the combination of methods like, and it's also in the introduction mentioned by Matthias, speaking about systems engineering and model-based system engineering, as well as agile engineering, we are able to collaborate simultaneously with all engineering disciplines within one model along the life cycle. Using these kind of methodologies on simulation, data analytics, and artificial intelligence, the digital twin enables us to analyze and to optimize and finally also verify the product and its behavior. And we can take into consideration all changes, requirements, the changes in use, environmental conditions that have been made. And based on these capabilities and possibilities, the real physical prototype, which has been done in the past very, very intensively and with high effort, become with these digital capabilities more and more obsolete. With the, I guess all of you know this phrasing, design for X or design for manufacturing, or PMI, which stands for product manufacturing information. During the product development, the engineers are already taking into consideration the production planning. So the objective of the production planning is to ensure a certain production output with regards to the product, and therefore also taking into consideration different criteria, like, for example, quality, time, and cost. So in the end, the digital production planning is taking into consideration all relevant assets and equipments, such as robots, cranes, and hardware and sensors, for example. So in summary, the digital production twin is representing the overall production, including programming of PLCs as well as HMIs, so human-machine interfaces, and as well as the behavior of the production. In the end, we are, like in the product twin, we are able to simulate and to optimize the virtual commissioning, so the starting and optimizing of the production planning just based on the digital twin. Last but not least, on the right-hand side, the digital performance twin, and sometimes there are difficulties to understand the difference between the product and the production twin. But the performance twin is the instantiated production and the product in the digital world. By the combination or by the connection of the digital and the physical twins of production and product, by a continuous data flow, which is going to be established, analyzed, and evaluated. So we are able to have a kind of continuous improvement on both product as well as on the production. So in the end, and that's also what Marie mentioned, the objective is to have a closed loop, so a kind of self-optimizing system along the whole life cycle. What's shown here on the next slide. So a holistic, interconnected, and self-optimized system along the life cycle from digital world across the real world. But to realize this end-to-end integration and interoperability along the product and production, it's necessary to have the right processes, methods, and tools in place. So that's what I try to figure around here and to place around here this cycle. By theory, as we can see here on the slide, in theory that's quite easy to paint or to put on PowerPoint. In the reality, I guess all of you are aware of the complexity, and that it is more difficult to make this happen on an end-to-end basis. And finally, that's why we are here. I guess that we only have solutions on some parts of this end-to-end story, and that just maybe in laboratory conditions it's possible to do it end by end. So what are we missing from our side? There are two challenges. One is on the technical, and the other one on the change management or organizational aspect. So there's still problems or lacking on data standards and structures, which ensures and enables a continuous and integrated data flow along the life cycle from end to end, especially in the very heterogeneous and the complex application landscape. All of us know from engineering with thousands of apps and applications, and as well in the production, where historically grown production environments we are facing. On the other hand side, what has been mentioned, we see organizational challenges which are coming along on introduction of new working methods, such as model-based systems engineering and agile engineering, agile development, which are, from my perspective, necessary and a baseline for realizing the continuous improvements along the life cycle. So it's more or less a change management topic for the people and organizations of the current industries. And as usual, so security and IT security aspects, they should not be underestimated, especially when we talk about connected products, thinking on cars with over-the-air updates, or also with cloud solutions and cloud services. We as Capgemini, we are working on solutions with our customers and partners, and we are trying to help you to leverage and to find solutions on digital twins along the life cycle. Being more concrete, in the following, I will present 2 examples from customer projects where we are working on that topic. And later on in the presentation, Marie will also give an overview on assets we have in Capgemini Group. And yeah, finally, what Matthias already did. So one last slide before we start with use cases from theory to praxis. I just wanted to put the 2 examples into the context. So as already shown, we have the engineering, the production, and the operations world with the relevant twins on product, smart factory, or production, and also the performance twins. In the chapters or in the rectangles, you can see some of the relevant processes, method, and tools which are necessary to establish, to build, and to manage the digital twins individually. And I think this is also representing and showing the complexity as such. And yeah, everybody is, I think, agreeing that it is even more complex to orchestrate all the 3 twins within one system. So what I will show to you is we have one example on the wing door, which is an example of aerospace industry. It is for the moment a production twin, a product twin. So it's just engineering, while we are aiming at connecting to production and as well to the real world, so to operations. The second example is on virtual commissioning, which is a kind of combination of the product and the production twin. So now, as promised, first example, over wing door. Yeah, it's the emergency over wing door of the A320 series, what we speak about here. And on this, we did the design of the model of the door as well as the context. So the design means that we did the engineering services. So that's maybe a kind of service we are let's say differentiating from our competitors, that we are also doing engineering work. And the objective of this design was to ensure the key requirements for the functioning of this door. So there was a requirement that the door has to open by a defined minimum angle to allow people to exit, by a defined maximum time to open, and with a maximum effort. What is to highlight on this model is it's a model as such. So it is built based on MBSE approach. We set up a so-called RFLP structure. RFLP stands for requirements, functional, logical, and physical structure. As you can see when you look from the left to the right, so there's a requirements tree. Then we have in the middle the functional and the logistic and the logical models, and they are linked to the physical model in the end. On the next slide, I will show you a simulation, what was based on the model we built. To highlight that this use case is built on the Dassault tool chain, and currently we are building the same use case or the same model on Siemens and IBM toolsets, and for sure that's also possible doing this with other editor tools like PTC, for example. So here you can see on the left-hand side the digital model we built, and on the right-hand side the real physical model from the A320. Just replaying. So you can see the movement of the individual parts and as well the assemblies. In parallel, we did some recording of the key criteria like the angle, the time, and the effort. And by the structure of the RFLP, we could easily identify that based on our design, the requirements were fulfilled. And imagine that there is a change of requirement, then you can easily simulate if the new design will, or if the old design will also satisfy the old requirements, or if you need to adjust the design. So that's also the advantage finally of the digital twin and on the connection end to end. So then coming to the next example, speaking about virtual commissioning. So virtual commissioning, this means that the planning of the production and the changes on it are done in the digital twin. So analysis and optimization loops are done until the right output criteria are fulfilled. In this case, it was to optimize the movements of cranes and the robots, including the programming and the PLCs as well as the HMIs. Just keeping in mind, and I guess everybody was in the production unit, what complexity we see there, then it's quite easy to understand that with changes you have to do, there is a possible loss of production time because of the standstill that might easily happen. All changes and modifications which can be done in the digital model will save time and standstill time and will increase the output. So that's just some of the advantages we have working in the digital world. Where does it make sense to build a virtual model and have virtual commissioning? So when you have a complex production environment with many interactions, when there's a lot of changes to happen in a short time, or when you are dealing with, let's say, expensive materials on the physical testing. Another advantage, or some advantages on top we have, and which are quite obvious, I think, and what already was mentioned by Marie, faster start into production. We are reducing downtimes and standstills, therefore having higher output rate. And it's also reducing the cost of the real production, for example, by the predictive maintenance. So in this case, what did we do for the customer? It was a kind of brownfield approach. So this means there was an existing production facility, and we did a full digitalization of the model with reusing the models of the customer. In concrete, there was a change on the product components of the fuselage of the aircraft. So and as a consequence of the product changes, so speaking about the digital twin of the product, we had to incorporate the changes as well in the production. So to adjust the flow of the production assets and to make, as I mentioned, new movements and new flow of the cranes, of the robots. So what we did is to simulate the changes in the digital production model. And looking into the picture, you can see from the left to the right side the different working steps. And the first is to reprogram the PLCs according to the new requirements or to the new movements to the new steps. On the second, we did the virtualization of all systems, including controllers and sensors. The third step was to connect this virtual hardware into the overall framework to be able to simulate the behavior of all the assets, such as the cranes, the robots, and the sensors. And finally, in the last step, it was a simulation in the digital world of the production, or the virtual commissioning with all the changes implemented. After successful testing of the new, let's say, codes and data in the digital world, it was rolled out to the real production unit, and then going live after final testing with the real world. Originally I planned to have a movie as well on this production unit, but I did not get the clearance from customer side. So the good news is that we are doing with our PLM community a showcase based on our own IP, and we will be happy to come back to you in case of interest on the virtual commissioning. So if you send a mail to Matthias, Marie, or myself, and then we are happy to come back to you and explain to you what we did and what we can do in this context of virtual commissioning. So thanks for listening to me out of the dark, and I will hand over back to Marie.
Okay, so now we're going to have a look at some best practices that we use at Capgemini. The first one, if you go to the next slide, please, thanks, is the methodology we use at Capgemini actually when we start or implement digital twin projects. So as you can see here, it's a 5-step roadmap. So first of all, of course, you want to identify use cases and target benefits. They can be very, very different depending on what industry you work in. For example, if you imagine production of a highly repetitive production of computer chips, might be totally different than if you think about production of totally customized airplanes that maybe the company is even maintaining by itself. Yeah, so you want to make sure what is the use case and what will be the benefits before you start. Then next step to do is to capture use cases, and after that put them on a roadmap. So define milestones, and what is also very important from our experience is that you identify quick wins. This will first of all help you to get the return on investment very quick, but also it helps to implement the change for the people that need to work with the tools. So if you find a quick small example that you can implement and that people find handy, that they say, okay, this can help me in my daily operational life, they will be a lot more likely to accept a bigger solution that you might want to implement a bit later. Yeah? So it's very important to identify some quick wins right from the start. After that, of course, you want to implement use case by use case to, in the end, achieve the full solution of the digital twin that you were aiming at the start. At the bottom of the page, you can also see how long it takes usually to do that. So the first step, where you do like a small exploration concept or maybe write down a project mission, will typically be between 1 to 3 weeks. At Capgemini, typical workshop for capturing use cases and defining roadmaps and quick wins will be roughly between 2 and 4 weeks. And implementing use cases, of course, depend on what tool you use, what methodology you use, and how complex the use case is, but roughly will be around 2 to 4 months. The full solution, of course, depends on how many use cases you have and how complex the solution is in the end. This is just a very, very high-level view of the roadmap. So we have a lot of material behind that. For example, how to define use cases, how to structure them, also how to prioritize, how to calculate return on investment, and so on. So if you're in the phase of starting or maybe already on the way of implementing the digital twin project and want more details or have a discussion around this, again, here we'll be happy if you contact us and we can enter in more detail to talk about how to do a digital twin project together with you. Okay, the next thing I want to have a look at quickly is our reference architecture. So of course, with digital twins, as with any IT solutions, if you implement them, you want to have a good plan about what your architecture is going to look like. And on this slide, you will find things that are very obvious. For example, at the bottom of the page, if you look at the input data, you will, of course, have a lot of different systems sending data. Yeah? This might be central IT, this might be embedded software from the devices that you're running. This might also be data from robots and machines running in your plants and so on. So you have a lot of different virtual and real data that you need to collect. And then on the top of the page, also not surprising, you have all the different applications working on them. Yeah? So you will have 3D simulation, you will have CAX, PLM, PDM, and so on. I think most of the applications you will know and be experienced with. So again, here, not very surprising, but there are 2 important points that I want to point out to you. So the first thing is the models dictionary that you can find on the right side of the slide. This is a repository where you keep your business objects and also the relation between them. Yeah, so as you have all the different applications and all the different systems sending data, you will have a lot of business objects that will be related, that might be similar but not same, and so on. So what you want to do in the dictionary really is to model the business objects that they are, the ones that you need, and also their relation, so that you can translate between the different systems. The second one that is very important from our experience is the semantic layer. This is a technical abstraction layer. It can, for example, be implemented using web services, and it's an abstraction layer between the input data and the application layer that will unify the way that you read and write data through the different layers. Yeah, so these 2 together, the models dictionary being more of a functional translator and the semantic layer being kind of a technical translator or emulator, will help you to be very flexible. Yeah, so that if something changes, either in the input or in the application layer, you can quickly readapt it to the system, and also if you want to build more use cases and flexibly extend your architecture. Yeah, these two will really help you to be flexible and extendable for the future. Again, here, this is just the high-level overview. If you're at the point where yourself are creating an architecture or thinking about changing your current architecture and want to have more details around it, we'll be happy to discuss with you if you just connect us. Okay, so much for the best practices. Afterwards, like now, one slide, as I promised, only one slide about digital manufacturing at Capgemini will be the last slide before the Q&A. So it's about how we do a manufacturing project at Capgemini. If you go to the next slide, please. Well, we really aim to offer end-to-end services. Yeah? Matthias in the introduction explained a bit that we have different global business lines working on different topics that allow us really to offer an end-to-end portfolio. Yeah? So from the early phases of strategy and transformation, where you think, okay, do I need a digital twin? And if yes, for what? What tools should I use? What is the right process for me? To the classical IT phases of design, implementation, maintenance, and operations. Capgemini also offers cloud services. So if you want to shift your solution to the cloud or need 24/7 support in the cloud, these are also services that we can offer. And most important for me in this case is also the engineering services. So we already have that today. Simon, for example, is from the Engineering and Manufacturing Services Department at Capgemini. And this will, of course, become very important with the acquisition of Altron, because this is their main skill. Yes, so this shows the importance of the topic for Capgemini. And if you implement digital twin projects, it's of course very good to have the combination, because you have the IT people who know how to implement and maintain the tools, and you have the engineering people who really know how to work with the tools, yeah? So who understand the intelligence behind it, and the combination of the two leads us to implement successful projects, yeah? Because the combination is important in that case. The approach we have in the project is also scalable. So we always have on-site experts that work with our customers, so that they will sit in the offices together with you. I mean, not today because of Corona, but hopefully soon again in the future, they will be in your offices and work together with you in your operational daily life. They are supported by a global digital manufacturing network that consists of center of excellences and communities. So people are connected to exchange, for example, on new trends of technologies, but also to compare different industry approaches and think about how can one approach maybe be applied to another industry and so on. It's also very important for us to work together with the partners. The ones you can see on the slide are just a few of them. But basically in the digital manufacturing area, you have the vendors like PTC, SAP, Siemens, and Dassault that offer all the different tools to implement digital twins. We do a lot of projects together with these partners, yeah, so working in a collaboration model. And also, if we deliver projects, of course, we get trainings and free environments and so on that help us to, for example, compare the different tools. Yeah? So we have many people in our teams that have worked with different tools. And if, for example, you wonder like, what might be the right tool for my case, in my industry, we might be able to help you there, because we have experience with different partners. Same, of course, for the cloud partners like AWS and Azure, because if you want to shift to the cloud, it might be very different if you do it on AWS or Azure. As we work with both, we can do independent consulting, of course, yeah, and give hints and compare what are the advantages and disadvantages. When it comes to scaling projects, we also have a very big digital manufacturing team in India, consisting of a few thousand employees by now. So this is, of course, important if either you have a very big project and you need the manpower, or also, of course, from a cost perspective, yeah, because it's, of course, more competitive pricing than what we offer locally in Europe, for example. And yeah, so these two together offering end-to-end in a scalable way. This is our way of working in the digital manufacturing area. So much from our side for now. So now I hope that you have some questions for us, so we will be happy to answer. Thank you for listening so far.
Thank you, Marie. We actually did get some questions in via the chat, so without further ado, I can start reading up the first one of them. And that is, to what extent is Capgemini Invent usually involved in the PLM related project? Assuming strategy and requirements planning is most relevant, but would love for you to elaborate.
Yes, exactly. It's in the early phases, like strategy and transformation, if you think about the portfolio, also in communications. They're also usually involved. And it depends on the project, a lot of times also in the process design, yeah, depending on what level.
And for sure on the change management, also when you speak about changing in new working models like MBSE or becoming agile. So for example, in Airbus, we are working on safe agile approach. And that's a classical topic where we get the support from our Invent colleagues on the change management aspect, which are strongly for sure related into the technical processes of the different industries.
Thank you. Moving on to the second question. How big is the difference between discrete manufacturing to process industries? For example, car manufacturing focused on design and building versus oil and gas rig focused on operational digital twin of assets. If you could elaborate on that.
Can you repeat the first part of the question, please? I understand the industries, automotive and energy, but the
I can do that. I just got another question and it moved, so I can read it again for you. How big is the difference between discrete manufacturing to process? Example, car manufacturing focused on design and building versus oil and gas rig focused on operational digital twin of assets. DIALM, I hope I'm pronouncing this correct.
Yeah, okay, no, understood. Well, of course, there's a huge difference. Yeah, it's not only between the industries, but also what you want to achieve in the industry. Yeah, for example, like for car manufacturing, they produce a lot quicker and a lot more products, for example, than in energy. Yeah, who might build one plant, I don't know, every year or so. Yeah, so you have another frequency. And for example, for the energy sector, the maintenance part might be a lot more important than it is for the automotive today. And so from industry to industry, it's very different, yeah, depending on the good. Also, for example, even in the car industry, if you look at cars or trucks, it's already different because trucks usually are highly customized, so every truck is different. Cars usually are flexible, but not as flexible as trucks. Yeah, so it's very different. But as I said, it also very much depends on what your goal is. Yeah, where you have to think about it first. So what you want to achieve, where does your cost come from, where do you want to have cost reduction, and how can this be applied to my industry? Yeah, so even if you just look at energy or just at automotive, even in there, the use cases are already very different.
And
thanks. And there
just
we go.
to add,
yeah?
Just to add what Marie mentioned is that we are having different, let's say, production units. So car is more a multi-product or mass product, while the plant design is more individual. In some cases, there are several industries, several plants built on the same configuration. But in the end, I did in the past also work on PDS, plant design systems. So I'm coming out of this PNID and piping and stuff like that. So I think that the digital twin on the plant design is more relevant on what the plant is producing. So when you speak about the materials, so when you segregate crude oil in the different fractions, so I think that's what I understood is more relevant for the simulation. And I think this is more complex in terms of simulation than what we are doing with the digital twin, for example, in discrete manufacturing on automotive. But in general, we are also having solutions and can apply solutions for digital twin in plant industries. And I personally think that's pretty much interesting field as well.
Thank you. Moving on to the next one. Please explain what you can do a digital twin on and what it is not possible to do a digital twin on.
Sorry, again, I just didn't understand it right.
Yeah.
Also,
please explain what you can do a digital twin on and what it is not possible to do a digital twin on.
okay, I mean, to the first part of the question is easier because I think it's almost doable on more or less anything. Yeah, even for example, if you look at medical devices, also today there's digital twins for medical devices like lung machines, or even like like heart implants and so on. Yeah, so you can. I think the question is more what you can't do a digital twin on. And again, here I think it's just a matter of what doesn't really make sense. Yeah. So, but I think you can do a digital twin for more or less anything if you find the right use case and the right benefits behind it.
I think what you have to bear in mind when you speak about digital twin is what is the payoff out of it. So what I try to explain is that it is very complex to build a network across the different disciplines. When we just speak about engineering, from the requirements at the very first until the real physical product. So when you want to apply a lot of changes along your product and you do a lot of variants and changes in the product, then this might really pay off in the end that you get when you change the requirement and you have at the end the ready EBOM. And when we speak about individual product design, then I think it does not make sense really. So that's for me the key question. And technically, a lot of things is possible, but the question is for me even more: does it really make sense? And what I also try to explain that we also have, let's say, some technical challenges in front of us, and we are still speaking about the old problems we have with regards to data formats, data model, which makes really a seamless data flow along the whole life cycle and enables us to use the data as it would be needed to really have the full flex model available. So I think problems known, we have some new technologies in place. So just mention the platforms which are offered by the different editors. We have cloud, we have IoT, we have some kind of flex data standards, but yeah, that's for me just one more step into this direction, but not really the solution for all.
Thank you. Now we have a question from one of our employees. As a Capgemini employee, how can we part of this PLM team?
But contact us, Matthias.
Matthias, huh?
Please, just call me.
There you have your answer.
Yeah.
Yeah. As I said, we are in a very connected community. So even if you're not from Sweden or not from Germany, we find you contacts in other countries.
Yeah.
Yeah. But I think this is a good feedback to us that this was so attracting that you want to be part of the team. So that's really awesome. Thanks for that.
Yes. And then the final one, also from one of our employees: will this material be uploaded to the PLM NSO page of the group? I can tell you that for Sweden, we have a webinar page where we upload webinars on demand, the recordings of the webinars, so it will be available there. I can reach out to you after this webinar and show you where that is.
Yeah. And they will also be available on our webpage, right? That's right.
Yeah.
Yeah, the recordings. Yeah. Yeah.
Yes, exactly.
Okay.
Exactly.
Yeah. Do we have any more questions?
No, this was actually it.
Yeah. Okay. I think the time is running out, so I think it's time to close. So thank you all for attending this webinar. I really hope that you found it interesting, and hopefully it gave some ideas or food for thoughts. And as we already said a couple of times, if you have any questions, don't hesitate to reach out to us, either me or Marie Fleur or Simon, and we will try to help you. Next week, we will have another webinar session, and then we will talk about how to simplify collaboration and the production of your products and services. So if you haven't already registered for that, please do, and I hope to see you then. So thank you all, and have a nice day.
Thank you.
Yeah, thanks for listening. Bye-bye.
Yeah.
Thank you. I just posted the link to the registration pages so you can look there for the registration. Thank you once again. Have a good day.
Thank you. Bye-bye.
Bye.